working on the neck drive. So the neck drive is what allows Johnny's head to go forward and backwards. This is quite a complicated little part here. As you can see, it's got a lot to it. I have this part here. That one's ready to go. I've also got this part here, which is ready to go. And I just received these today. So this is quite a complicated piece here. I mean, you could, in theory, you could have this laser cut and then, you know, do some of this other machining yourself. But I chose to not go that route and have it CNC'd. And here's the other side, the other part. Now, I still got to go through and I got to tap these holes here and make some other custom parts that's going to go along with this. So basically, this turkey neck system, it sits underneath this cover here. I've seen these covers before. So there it is underneath there, right underneath the neck cylinder manifold and everything. And then what it does is it basically does this, where you take the neck and it does this with the neck. That's what we're building today. We are going to tap this guy to 1/4-28 thread. So 1, 2, 3, 4. So what I like to do is I have this little bright vise here. Lets me hold everything in place. Granted, the vise itself is not bolted down, but it does the job. And then we gotta find our 1/4-28 tap. Bottom tap is something you use whenever you have a hole that doesn't go out the other end and you want to make sure it's threaded all the way through. You would use something like this because the threads are pronounced all the way to the end, whereas on this one you can see it's tapered. So this will be a good starter tap. I don't need to do a bottom mount tap in this operation because the holes go all the way through. So then we find our adapter here. Not it. Nope. There we go. Okay. Stick it in here. Add me some oil. Definitely want to lube your parts thoroughly. And then we go away to tapping. Aluminum is far easier to tap than any other material that I have worked with. Steel is a real pain in the butt. And I have definitely broken taps. The good news is if you break a tap off in aluminum, you can get it out. Even if you can't necessarily remove it whole, you can, sometimes you can drill them out, but in aluminum, you can actually use some material, and I can't recall what it is off the top of my head, but there's a chemical you can use that actually eats away at the steel tap, but it leaves the aluminum unharmed. I've had to do that. So I got a tap stuck in a piece of aluminum that I really did not want to lose that part. So I Googled it, found the chemical that worked, something you just buy off the shelf, and let it soak in it, and that stuff became really super brittle, and I was able to take it right out of there. So, moral of the story is, don't give up. There's usually a way. This definitely gives you an arm workout, I'll tell you that much right now. All right, one down. Now I usually like to run the tap twice because running it once, it generally is not, yeah, see that screw, it'll go, but it doesn't want to go very good. So I typically run it twice. And I'm just going to need oil on it, because it's just basically going to clear the threads. Now think about this. This is one part of many parts that go into this build. And I mean many parts. So you can imagine this project has taken quite a while, between the fact that you gotta have the money to buy either the parts or the materials or the equipment. And then, yeah, there we go. See, I can actually turn that with my hand. So that's pretty good. And then, oops, that is not the next hole. This is the next hole. And then the time to assemble it. Do these small operations and assemble it. And, you know, I could sit here and spend half an hour, well, maybe not half an hour, but 15, 20 minutes probably tapping this out. And then, you know, on to the next small operation I got to do, that small modification here and there to get this thing assembled just for the head to move forward and back. It's quite amazing. You know, you think about the human body and all the functions that it can do, and when you try to replicate that in a robot, it takes so many different operations and so many well, even pieces of code to make a simple movement happen that we basically take for granted with our own bodies, that they just do what we think they should do when we think, you know? And you don't really appreciate that until you have to build a robot. And then when you're building a robot, you're thinking, okay, well, how hard can it be to make a head go forward and backwards? And then you realize, oh, I need this part in this place and this chain and this servo, and once I get all the hardware together, then I've got to tell it to do that. It really is quite amazing how complex it can be. All right, I've run that twice now in that hole. We got 2 more to do, and then we'll be done. And I chose not to have this tapped when I had it CNC'd because it's an extra charge. And as you can see here, it's not incredibly difficult to do it if you have the equipment, which obviously I have, because I needed this for a lot of tapping operations on the cradle base, which is the bottom of the robot. That we'll show in a future video. Well, I'll show in a future video once I get to that part of it again. And I think I might have to adjust this. And so, you know, why pay for more than you need to? Things are expensive enough as it is. Probably when it's all said and done between all the equipment. So I get this question all the time. How much does it cost? It costs a lot of money. There's no joke about that. And did I plan on spending this much money? Probably not. I went into it, you know, pretty much told myself if I could get the rare parts it takes to build Johnny 5. The lenses, the eyes, those are very rare lenses. The rear tire tread, that's a very rare part. There's certain parts of the robot that you almost absolutely can't even get now, and I had bought those about 5 or 6 years ago. And I told myself, if I buy those rare parts, if I can get a hold of all those, then I will build this robot. That was kind of I actually didn't think I'd get them. I actually did not, at the time it was actually easier obviously than now, but I actually did not think I'd get all the rare parts that I've gotten to complete this build. And here we are. I told myself I'm not going to stop at this point. I'm going to get it done. And I've been chugging away at it ever since, but throw in all the equipment that I bought for this. So the lathe, this tapper, the 3D printer. I mean, I bought all that for this project pretty much. And I've learned a lot from it. That's one thing about doing a project like this, is that you learn a lot about a lot of different things. Anywhere from machining to programming, 3D printing, all that. It's very much an experience in that regard. And so yeah, I mean, you throw in all the individual parts, the bolts and the screws, and that doesn't even count the time that I've spent doing this. And I enjoy doing it, so don't get me wrong. I mean, I'd rather not have spent this much money, but I've enjoyed doing it, and it really is a good pastime for me. And like I said, I've learned a lot from it. So even if at some point when I do get done, I will have a lot of additional skills that I didn't have when I started the project. So that is that. Get all the nastiness off here. And that tap, it does kind of, you know, put some edge on here. I've got a tool that'll deburr that. So that'll be good. So then now what we're going to do is we're going to take these screws in the other half, and then we'll put this together, because what I need to do is I need to place these together in order to machine some other parts for this piece here. And I don't want to do it without it together, because I want to make sure that the measurement's dead on. The CAD is accurate, but the operation, when you go from the CAD to an actual physical part, there is some, I guess, margin of error, simply because, you know, this was machined by somebody, I'm machining this other part. What tolerances did they use when they made this part? It's hard to adjust for that when you're not the one making the parts. So it's best to sometimes assemble the part, two parts together, mark where you're wanting to make the modification, and then do it, as opposed to following the CAD directly. So that's what we're going to do next. So that's after the tapping operation, and I've fit all the bolts in here together. Look at that, it's starting to look like the drawing. Check that out. All right, so the next operation I'm going to do is work on this little tensioner here. So we have this tensioner right here. I'm going to hide this side. So the chain goes through here, and then it's got this tensioner that pulls the chain down, or this gear, the screw pulls this sprocket down and tensions that chain up. So requires this little guy right here to be created. So I've got the shaft. It's already it's a D style, meaning that it's you know, it's got that bevel, or it's got that flat side on it. So this is what I was talking about before. I can go measure this, but look at this. I can stick this in here now, and I can basically mark right there how long I need it. I'll chop it off. I'll clean it up. And then the bolt goes through here, and it goes through this, and then it obviously, you know, adjusts up and down this way. So what I can do is once I get this cut, then I can put a mark go inside here, put a mark on the rod on both these, and then I'll know exactly where to drill it. Got that part in, cut it off. Basically use that guy to cut it off. And then I use this guy to deburr it a little bit. And then to even out the edge, I threw it in this lathe real quick and just nipped the end slightly to make it where it was. And then of course, validated it with these, because I still do want to make sure I'm as close to spec as possible, even though I did rough mark it. Rough marking it does well to do the coarse cut, and then after that you want to try to use the spec and the calipers there. Yeah, it looks pretty good, right? All right, here's the fun part. Got to put holes in it. So I got my marks on there. I've already drilled one of them. So it's kind of a before and after shot here. Yeah, my ways are somewhat unconventional, but it gets the job done. Using this drill press, this clamp. It might be some redneck science, as Weston says on YouTube, but it gets the job done. And hey, if you can afford a mill, more power to you, because that definitely saves you some hassle. But this is what I got, and I'm gonna make it work. I think the first thing I'm gonna do is show you that not everything always goes by the CAD. So for example, this sprocket here, the way it's supposed to work is you're supposed to, so I had to machine this part here, and so I had to machine this part here out of steel, and I had to basically drill it and then fit it to where, let me show you. So this is the servo. This is the servo that's going to manage do the neck, and this is the sprocket that you're supposed to put on here. Now, the way it's supposed to be designed is it's supposed to have a keyway, and then you have to notch this piece of steel, and that'll help it, you know, not spin on here. I don't have the right equipment. I don't have a mill to do that kind of work. So I've come up with a different way of doing this, which totally is fine. Took me a little bit to figure it out though. So basically what I did is I got a longer screw here than what you normally set screw, a longer set screw here. So normally it has this little set screw, and I took this piece and I drilled it out. So basically I'm kind of making my own keyway in a way. The goal is for none of it to be able to spin. So this goes down in here. What's cool about this is that the set screw goes all the way through and then comes out down here. So then this guy goes on here. This has got a flat end. So just line this up where the set screw is, well, yeah, it's where the set screw is on the flat side. And then we'll tighten this up. Make sure that I'm aligned. Just like that. And that's not going anywhere. So that set screws come all the way down through, and it's basically landed on that piece inside there. So then I'm going to take the second set screw, go ahead and put it in. It's not going to go all the way through, but it will help keep the steel piece that I drilled where it's supposed to be. So I think that's a pretty good solution. I think that'll work out just fine. I can't imagine that's going to spin. And if it does, I'll address it at that point. But I'm pretty happy with that solution. I had a very poor attempt of trying to make a keyway. I bought these things without a keyway. I thought, well, I could just make a keyway. Yeah, that didn't work. So, but luckily enough, I figured out a different way to do it. Then, what we got to do is I've got to finish putting in the servo bolts here. I'll tell you one thing, if you buy bolts, buy them by the bag. It does not matter if you need 10 or 100 of these things. I'll tell you one thing that I have learned doing this robot. One, when you buy them in the bulk, they're cheaper. They're cheaper ultimately. And then 2, you have spares. And 3, when you run into situations just as I did here where I needed a 1/4-20 set screw that was longer than the ones that came with these, I had a whole box of them because I bought them for another part of the robot, and I was able to use it and not worry about stealing it for something else I might need. So it just, and then not only that, you end up, sometimes you'll be working on it and you'll realize, just as I did on this part, I forgot to buy the 540 screws, I forgot to buy the 540 screws. Instead I'm going to use 440s here, which honestly they'll work just fine. All right, so I tell you what, I spend more time looking for parts. So I found the part I was looking for. I was trying to find this bearing that goes in here. This is supposed to be a flange bearing. Buy this flange bearing, FR8ZZ from Bearings Direct. Got the bearing, validated the part number, threw it in the box. Didn't think anything else of it. This was probably 6 months ago or more. Go to get the bearing out. It's not a flange bearing. Of course, I can't return it at this point. So what I'm going to do is I'm going to go ahead and mock this up. I've already got this bearing reordered. I actually found it on Amazon, and it's 4 of them for $10. So I really can't beat that price, and it'll be flanged. So the flange bearing, the purpose of that is that was not supposed to happen, is this. This off here. It's got this flange here. So correct bearing, when it goes in here, it'll keep it from doing this, pushing through. So we definitely don't want that to happen. So we're gonna get the right one, but for the moment, I'm gonna go ahead and mop this up to make sure that everything else is good to go. And then I